All right, we're back. We're going to wrap up section 1.3 today, so video 1.3b we'll call this. And we'll start off with identifying outliers. We kind of mentioned that before. We saw some of them, and we didn't really have kind of a way of identifying that or qualifying that. Just kind of, it looked like one. So here's one way. This isn't used all the time, but certainly one way that you can identify an outlier. It's called the 1.5 times interquartile range rule. All right, so call an observation outlier if it falls more than 1.5 times the interquartile range above the third quartile or 1.5 times the interquartile range below the first quartile. So in other words, once you know the interquartile range, multiply it by 1.5, subtract it from the first quartile. Anything below that is an outlier. If you take 1.5 times the interquartile range and then add that to the third quartile, anything above that is an outlier on the high side. Okay, let me show you how this works. So we've got this identified already out here. So the first quartile is 22.2. Third quartile is 22.6. So the interquartile range is 0.4. So if we multiply that by 1.5, that's going to be 0.6. So if I subtract that from the first quartile, all right, 0.6, we're going to get 21.6. And if I add that to the third quartile, it's going to be 23.2. So we'll kind of mark those on here of where we go. And then you can kind of see that, oh, yeah, looks like we do have two outliers here, don't we? Yeah, according to this rule. Sorry for the misspelling there. All right, so again, we would say cars, and again, we always want to use the lingo here and identify what these are. Put it in context. In other words, the cars with a fuel economy rating of 21.5 and 23.3 miles per gallon would be considered outliers by our rule, or 1.5 times the interquartile rule. Okay, so again, the question might be why? Why look for outliers? Well, they might be inaccurate data values. Might have been some inaccuracy in what you measured. Maybe something ridiculous is happening, remarkable, right? And then again, they can heavily influence those statistics that are non-resistance, things like the mean, the range, the standard deviation. So we might just even want to throw those out sometimes. All right, now the 5-number summary consists of these 5 numbers: the first quartile, the median, and the third quartile, and the minimum and the maximum. Okay, and again, we've done that before on the calculator in Algebra 2, where we have found those. It's kind of slick on how you do those, and you can do those by hand now fairly easily too for small data sets. But again, we'd compute this according to this data. We'd put the numbers in, we'd figure out here we are. All right, so now the question might be, okay, now we're gonna kind of look at this and summarize this with what we call a box plot, if you remember what that is. We use that 5-number summary. All right, now, what do you do to make a box plot? We find the 5-number summary. We can use the calculator to help us with that if you want to. We're going to identify those outliers. All right, so we have those on there. Now, look, we do have 2 of them here. We're going to draw and label the horizontal axis. And again, we want to make sure we're going up by equal increments. Make sure we label it. Yeah, we've got that. Okay, so scale it. We're going to draw the box. Now, again, the box goes from the first to the third quartile. That's the interquartile range right there. Going to mark the median with a line. And we're going to draw the whiskers. Now, the whiskers now are going to be drawn to the last data value that isn't an outlier. And then we're going to mark those little stars there where those outliers are. Okay, so we're kind of kicking those out for min and max. But we are going to say that there are a couple values there that are on there. We're going to star those. All right, now again, so box plots, they don't display each individual value. Okay, so they kind of show, broken up into force basically is what they do. They don't really show gaps or clusters or peaks either. So sometimes the box plot may or may not be the greatest thing in the world to list. You can see here with the dot plot put on here, you maybe get a little more information from the dot plot, but the box plot can be used just like I said, another visual that we have there, but it has limitations there. Okay, remember those learning targets that we had here today? So again, we had a little new thing with the interquartile range rule today, and we're going to make and interpret those box plots and work on those and make sure we're using those models. Look at those solutions and make sure we're not leaving anything out. Okay, those can be some easy points on the AP test, making that box plot, and then be able to compare those with comparative data. So that's it. So that's 1.3. That marks the end of our first chapter, and so we will get ready to go. We'll wrap up some problems here. We'll do We'll look at doing some little assessments here as we get going here, review for that. And until next time, I'm Mr. Boone.